Hello everyone. Since this is a short week and we're not going to be having a virtual lesson, I'm going to make this video for you for graphing sine and cosine so that you can see examples similar to those you'll find in the homework for 4.05a and b. So let's quickly review the unit circle. The graphs of trig functions are determined by referencing their values on the unit circle. So basically, if we want to graph sine, we're just plotting the points and connecting them, and same for cosine. So it's important to know the values of the unit circle. Keep in mind that these special reference angles in the unit circle, these x, y points, the x values represent the cosine, and the y values represent the sine. So all of these numbers are cosine, sine. So hopefully you knew that already. So if you were asked, what's the sine of 120 degrees? Well, it's the y value. It's root 3 over 2. If you were asked, what's the cosine of pi? It's the x value. It's -1. What's the sine of 5 pi over 3? The y value, -root 3 over 2. So the unit circle is a quick and easy way to determine the sine and the cosine of any angle on the unit circle. So when we graph sine and cosine, we're not going to plot every single point, 30, 60, 45. We're just going to plot the quadrant angles, which are 0, 90, 180, 270, and 360. Plot those points and then connect them with a smooth curve. So let's fill in this chart. What is the sine of 0? So I don't have to scroll back and forth. I sketched a little unit circle here, and I'm going to plot my 4 quadrant angles. The coordinates, this coordinate would be over 1 up 0. This coordinate would be over 0 up 1. This would be over -1 up 0. And then down here at 270 would be over 0 down 1. So using these, I can quickly determine the sine of all of the angles in the chart above, because sine is the y values. So sine of 0 is 0. Sine of 90 is 1. Sine of 180 is 0. Sine of 270 is -1. And sine of 360 would just be back at 0, a full rotation, which would also be 0. And now let's go ahead and fill in the cosines. Cosine of 0 would be 1. Cosine of 90 would be 0. Cosine of 180 would be -1. Cosine of 270 would be 0, and cosine of 360 would again be 1. So I'm going to use the values in this chart to show you how to graph sine and cosine, the parent graph, without any transformations. And then we'll talk about transformations. So first let's do sine. Now I'm just going to do one revolution, which is 0 to 360. So my graph's going to start at 0 and end at 360, and because the unit circle repeats itself every 360 degrees, the graph of sine would repeat itself after every 360 degrees, but I'm just going to graph what we say is one period. So I'm going to divide my graph into 4 equal intervals, which end up being the quadrant angles we just looked at. 90, 180, 270, 360. Notice that sine ranges from -1 to 1. -1's the lowest value, 1's the highest. So my amplitude is 1. So it's going to go, the highest it's going to go is 1, the lowest it's going to go is -1. So I'm going to set up my axes like that. So now I'm going to plot my points. So if I backtrack, the sine of 0 is 0, and the sine of 90 is 1. So 0, 0, sine of 90 is 1, sine of 180 is 0, sine of 270 is -1, sine of 180 is 0, sine of 270 is -1, and 360 is back at 0. And connect with a smooth curve. And this is what one period of the sine graph looks like. If I were to sketch more than one period, like let's say that's one period, it would just keep repeating. like this. That would be 2 periods. And then, so it repeats indefinitely. So our domain, we say, is all real numbers because the graph extends on to the left and to the right, and there's no domain restrictions. Every value has a sign. So I'm going to say all real numbers here. And the range is not all real numbers. It's from -1 to 1. So y goes from -1 to 1 and hits all values between. And that's the parent graph of sine. Let's take a look now at the parent graph of cosine. Cosine also ranges from 1 to -1, and we're also going to graph one full period, which is 360 degrees. So I'm going to divide it up into 4 equal intervals. 360 divided by 4 is 90, so the intervals go by 90. Now, just to show you radians too, because sometimes you'll be graphing in degrees, sometimes you'll be graphing in radians. If you were graphing in radians, you would just be using the radian measures. But it's the same idea, depending on how you're graphing it. And then if we go back to the chart, cosine goes like this: 1, 0, -1, 0, 1. 1, 0, -1, 0, 1. So 1, 0, -1, 0, 1. And sketch it with a curve. And the parent graph of cosine looks like this. It looks like a U. So although it looks like a U, keep in mind that if you were to graph more than one period, you would keep continuing the pattern like this. So this would be 2 periods. So it actually does resemble the sine curve a lot, depending on how many periods you're graphing. But when you only graph one period, cosine looks like a U, and that's a good way to memorize what the graph of cosine looks like. So the domain, because it goes on in both directions, is all real numbers. And the range is going to be the same as for sine, y values between -1 and 1. So if you wanted to find the x-intercepts, you could take a look at the graph. You could see them there, and those x-intercepts would repeat every 180 degrees. So you'd have another x-intercept at 270 plus 180, and then another one 180 degrees after that. Okay, now let's talk about transformations. The graph of sine and cosine, they're periodic functions, meaning they repeat after one period. So one standard period is 360 degrees, or if you're talking radians, 2 pi. The amplitude generally goes from -1 to 1. But just like with quadratics and linear functions, once you start putting numbers in front and numbers inside, things change. So here's the general form of sine. A sine bx minus c. A, the number out front, represents the amplitude or the height of the graph. A represents how high and how low the graph goes. If A is 5, it's going to go up to 5, down to -5. If there's a negative out front, that just means you flip the graph. And we'll do an example of a flipped graph soon. Just like the negative flipped all the other graphs we've done. The period is usually 360. But if you have a value in front of the x, so like sine 2x, that would be a value in front of the x, the period changes. And the period changes by dividing by that b value. If you're dealing with radians, you're going to do 2 pi divided by that b value. If you're dealing with degrees, you're going to do 360 divided by that b value. Let's do some examples. We're not really going to do phase shifts left and right. We're going to mainly just do amplitude and period. So for our first example, we want to state the amplitude and period and graph from 0 to 360. Well, the amplitude is the number up front, which is 3, and the period is only changes if there's a number in front of the variable, the theta or the x, and there's not. So it's just going to be a standard period of 360. So to graph this, you're going to go up to 3 and down to -3. And you are going to have a standard period of 360. So 360 divided by 4 is 90. So your 4 equal intervals are going to be going by 90, just like we're used to in the parent graph. Nothing different there. And then from here you graph it. So it's going to be sine. So if you want to scroll back and look at the parent graph for sine, you can rewind. But sine starts at 0, goes up to the max, goes back down to 0, goes down to the minimum, and goes back to 0. So this is what my graph looks like. It has a vertical stretch of 3. It's vertically stretched. Okay, let's take a look at this one. State the period and amplitude and then graph -5 cosine theta from 0 to 360. So the amplitude's 5. You always give the amplitude as positive. It's not -5, it's +5. The negative's going to tell me to flip it. The period remains unchanged again because there's no number in front of the theta. So we're going to label our y-axis from -5 to 5, and we're going to do a standard period so we know how that goes. And then cosine's the one that looks like a U. So if I were to scroll back to the parent graph, it would look like this. It would go max, 0, min, 0, max. Because it's flipped, I have to do the upside down U. So let me sketch the regular cosine graph as a dotted line to help me sketch the new graph. So this is what it would be if it were not flipped. I'm going to use that to help me flip it. So to flip it, everything reflects across the x-axis. The zeros remain. Okay, so a flipped cosine graph really is just an upside down U. So that would be my graph in blue. If you were doing a flipped sine graph, you would just go down instead of up, and it would look like that. So that would be like a flipped sine graph. So keep that in mind. And I think we have time for one more example before my recording cuts off at 15 minutes. So let me quickly talk about this one. Here I have y equals 1/2 sine 3x. So my amplitude is 1/2, and my period is going to be standard period divided by b value. It's 120. So whenever your value, your b value, is bigger than 1, your period gets smaller, and whenever it's less than 1, it gets bigger. So 3 is bigger than 1, so my period got smaller. So, it wants me to sketch from 0 to 360. So 1 period is 120. And then it wants me to sketch until 360. So let's see how many periods. That would be 120 plus 120 plus 120. So I guess I have to sketch 3 periods now. That's okay. So that'd be 120, 240, and 360. And I'm going to go up to 1/2, down to 1/2, -1/2. Each period gets divided into 4 equal intervals. $120 divided by 4 is 30. So it's going to go 30, 60, 90, 120, and that's 1 period. So now I'm ready to sketch. It's not flipped, so I'm going to start at 0, go up to the max, back down to 0, down to the minimum, back up to 0, and that's going to give me 1 period, and then do that again, and again, And then we're all set. We've